Alright, Math 1060 Trigonometry. We're in section 1.1. We're going to talk about angles, both degree and radian measure. So if you've never talked about radian measure of angles before, now is your chance. Although I do think that was a Math 3 topic. So this should be a review. So an angle is two rays with a common endpoint, which we call that endpoint the vertex, right? So that would be, if I had something like, here, let me pick one with an arrow on it. The ray has an arrow on one end and not on the other end. The endpoints are together, so that's called the vertex, right? So there's an angle. The measure of an angle is the space, kind of like the space between the two rays, but it's more a measure of the rotation between the two rays, right? So when we think of space, we think of area, and there's less space down here near the vertex than there is up here by the arrows. So I'm not sure if space is a good definition for that, but the amount of rotation. Okay, an acute angle is less than 90 degrees. A right angle is exactly 90 degrees. That's where you get your nice corners. So all the corners on all these boxes are what we call right angles. If I do a little square in there, that's a symbol representing this is a right angle. It's 90 degrees. Obtuse angle is more than 90 degrees. A straight angle would be 180 degrees. Supplementary angles are two angles that add up to 180 degrees, and complementary angles are two angles that add up to 90 degrees. So if I don't know if you've heard all this vocabulary before, but here it is, just to review. The picture of the angle I created is an acute angle because it's smaller than a 90-degree angle. Sometimes the word acute can be used to mean sharp, like a sharp pain. Well, I don't know if you noticed, but that angle, if you think of it as the blade of a knife, is kind of a sharp angle, right? So acute. Whereas obtuse is a wider angle. So I like to relate it to the word obese. An obtuse angle is obese. I don't know, just little tricks to help you remember things. Not that we really need to absolutely be able to define these words. You just need to, they need to be secondhand, because trigonometry is about angles and triangles. And so you've got to just understand if the word right angle is mentioned, you need to know exactly what that is. Okay, do you need a little more time on this page, or are we good? There are three different ways we can measure angles. One way to measure an angle is the word revolution. Sometimes we just abbreviate it REV. And one revolution means one time all the way around the circle, right? So one revolution is equal to how many degrees? 360, yeah. So I don't know if we need to actually write that down because that's a fairly obvious conclusion. Find my... So one revolution equals 360 degrees. Okay. Another word for revolution is rotation, one rotation, right? So with degrees, that's what we're kind of used to using more than anything else. Degrees, we have 360 degrees in one rotation, and I think that goes back to ancient civilizations that approximated the number of days in a year, the number of days it took for the sun to come back to where it was. And we now know it's 365 1/4, but I'm pretty sure if you look up the history of degrees, that's where it's based on, is kind of the number of days in a year. So a lot of the math that's been created for us to use goes back a long ways into human history. Radians is a whole different way of doing things. So I might actually redraw this a little bit. A radian is the angle formed at the center of a circle for an arc of 1 radius length along the circumference. So, in other words, if we take the radius of a circle, so I'm going to highlight that right here. So the radius of the circle right there. If we were to take that measurement with like a string or a tape measure or something like that, what do I have in my drawer that I can measure with? And then we take that measurement that was straight across and we curve it around the edge. That's why I said a string. You take that string and curve it around the edge of the circle so that the length around the circle is still the same length that it was across, halfway across the circle, because that's what the radius is, right? Then you get the angle for 1 radian. So in other words, and I know that I kind of just, when I drew this last year, I just kind of eyeballed it, estimated it. So this radius of my circle around the outside, this is supposed to be approximately the same length as this. I don't know if I managed to get it that way or not, because I think if I look at this a little closer, it looks like the green and red ones are longer than the blue one. The blue one probably should be a little bit bigger, but this is just for demonstration anyway. So there's 1 radius length around. I'm going to take that same radius length. There's 2, there's 3, there's 4, there's 5, there's 6. But 6 doesn't fit perfectly. There's a little left over. Why is there a little bit left over? Why isn't it just 6? Wouldn't it be nice if it was just 6? It has to do with pi. Yep. That's why it's not exactly 6, because pi is not exactly 3. So where radians comes from is it comes from the circumference of a circle, because that's what we're doing, right? We're measuring radius lengths around the outside of the circle. That's the circumference. And the circumference of a circle is literally 2 pi. And so if radians is the number of radius lengths around the circle, then there are 2 pi radians in one circle. So if you think about what pi is, 3.14 approximately, you multiply that by 2, that's 6.28, right? So that means we have approximately 6.28 radians around a circle. Now the thing is, we don't like things to be approximate. Whenever possible, we like things to be exact. We like to leave logarithms exact, right? We like to leave square roots exact. We don't like to get those decimals that go forever and don't terminate or repeat. And so because of that, even though it's technically approximately 6.28 around the circle, we are going to do these radian things in terms of pi. And so in terms of pi, all the way around the circle is 2 pi, because it literally fits around, the radius fits around 6 and a little bit, or 2 pi times. And so if we talk about individual angles relating to that, we do them in terms of pi. So that's what our radians are going to be based on that we're talking about today.